Welcome, and let us venture into a world often overlooked, a world that exists right beneath our feet. Here we find some of nature's most extraordinary architects. They are not grand beasts or colorful birds. They are small, humble insects, the termites. Many people only know them as pests, but that is a very small part of their story. These tiny creatures possess astonishing building skills that can rival our own. They work together in the millions, creating complex societies and structures that are truly a marvel of the natural world. Their collective effort allows them to achieve feats that seem impossible for such small beings, demonstrating the immense power of cooperation. Termites are social insects, much like ants and bees. They live in large, organized colonies where every individual has a specific job to do. There is a queen who lays thousands of eggs each day, ensuring the colony's survival and growth. There are soldiers, equipped with powerful jaws to defend the nest from predators like ants. And then there are the workers, the true builders and providers of the colony. These tireless workers are responsible for gathering food, caring for the young, and most impressively, constructing and maintaining their magnificent homes. This division of labor is incredibly efficient, allowing the colony to function as a single superorganism, all working towards a common goal. The most visible evidence of their incredible teamwork is the termite mound. These structures can be seen dotting the landscapes of Africa, Australia, and South America, some reaching astonishing heights. From a distance, they might look like simple piles of dirt, but they are far more than that. Each mound is a carefully engineered city, a fortress designed to protect the colony from the harsh world outside. The sheer scale of these constructions is breathtaking when you consider the size of the builders. It is as if humans were to build a skyscraper several miles high. This is a testament to what can be achieved through persistent, collaborative effort over many generations. These mounds are not just homes, they are complete life support systems. They are built with such precision that they can regulate their own internal climate. The termites build a complex network of tunnels and vents that allow air to circulate, keeping the inside temperature and humidity remarkably stable, even when the outside weather is extreme. This clever design ensures the colony stays cool during the scorching heat of the day and warm during the cold of the night. It is a brilliant solution, a natural form of air conditioning that has been perfected over millions of years of evolution, showcasing the ingenuity that can be found in the smallest of creatures. So, how do these tiny engineers construct such colossal structures? The secret lies in the simple materials they have at their disposal. Termites do not have cranes or bulldozers. Instead, they use the very earth beneath them. The workers gather tiny particles of soil and clay, mixing them with their own saliva and feces. This mixture acts as a remarkably strong cement. Bit by bit, pellet by pellet, they build the mound's thick, protective walls. This process is slow but relentless, with millions of workers adding to the structure day and night, creating a fortress that is as hard as concrete and able to withstand the forces of wind, rain, and even fire. The design of a termite mound is a masterclass in functional architecture. The outer walls are incredibly thick, providing a formidable defense against predators. Inside this fortress, a labyrinth of chambers and tunnels serves different purposes. Deep within the mound lies the royal chamber, where the queen and king are protected. There are nurseries for the young termites, gardens where they cultivate a special type of fungus for food, and storage areas for wood and other plant matter. It is a bustling, self-contained city, hidden away from the dangers of the outside world, a perfect example of how to create a safe and stable environment using only natural materials. One of the most amazing features of these mounds is their ability to breathe. The colony, with its millions of inhabitants, produces a great deal of carbon dioxide, just as we do. This gas must be removed, and fresh oxygen must be brought in. The termites achieve this through a brilliant system of passive ventilation. A large central chimney rises through the mound, and a network of smaller tunnels connects it to the outer surface. Hot, stale air rises up the chimney and escapes, while cooler, fresh air is drawn in through the smaller vents at the base. This constant airflow keeps the colony healthy and thriving. This natural air conditioning system is so effective that the temperature inside the mound barely changes, regardless of the weather outside. On the scorching African plains, where daytime temperatures can soar, the inner chambers remain cool and humid, providing the perfect conditions for raising young and cultivating their fungal food source. This incredible feat of climate control is not achieved through any conscious planning, but is the result of instinct, honed over countless generations. It is a powerful reminder that nature has often found the most elegant solutions to complex engineering problems long before we have. Beyond their remarkable building skills, termites play a vital role in the health of their ecosystems. They are nature's great recyclers. Their primary food source is cellulose, the tough material found in wood and dead plants. While most animals cannot digest cellulose, termites can, thanks to tiny organisms living in their guts that help break it down. By consuming dead wood, fallen leaves, and dry grass, termites prevent these materials from piling up. They are the cleanup crew of the natural world, tirelessly breaking down organic matter and returning its nutrients to the ecosystem, ensuring nothing goes to waste. This process of decomposition is absolutely essential for life on Earth. When termites break down dead plant material, they release valuable nutrients like nitrogen and phosphorus back into the ground. These nutrients are then available for living plants to absorb through their roots, helping them to grow strong and healthy. Without termites and other decomposers, these nutrients would remain locked away in dead wood for years. Termites speed up this cycle of decay and renewal, acting as a crucial link in the food web. They are the gardeners of the forest and the savanna, ensuring the soil remains fertile and productive for future generations of plants. The tunneling activity of termites also has a profound effect on the soil itself. As they dig their vast underground networks, they mix and aerate the soil. This process, known as bioturbation, is incredibly beneficial. It helps water to penetrate deeper into the ground instead of running off the surface, which is especially important in dry climates. The tunnels create channels for plant roots to grow more easily, and they improve the overall structure of the soil, making it less compact. In many ways, termites act like tiny plows, constantly tilling the earth and keeping it healthy and full of life. The impact of this activity is enormous. Studies have shown that areas with healthy termite populations have richer soils and more robust plant growth. They can even help to combat desertification by improving water retention in arid lands. By enriching the soil and recycling nutrients, termites support the entire ecosystem, from the smallest plants to the largest animals that depend on those plants for food. They are a keystone species, a group whose presence has a disproportionately large effect on its environment. Their quiet, hidden work is fundamental to the health and stability of some of the world's most important habitats. The genius of termite architecture has not gone unnoticed by humans. Architects and engineers are now studying termite mounds to learn how we might design more sustainable and energy-efficient buildings. The way termites cool their homes without using any electricity is particularly inspiring. This concept, known as biomimicry, involves looking to nature for solutions to human problems. By copying the passive ventilation systems of termite mounds, we could create buildings that stay cool naturally, dramatically reducing our reliance on power-hungry air conditioning units and lowering our carbon footprint in the process. One famous example of this is the Eastgate Centre, a large office and shopping complex in Harare, Zimbabwe. The building's designers were directly inspired by the local termite mounds. Instead of a conventional air conditioning system, the building has a series of large chimneys and vents that draw in cool night air and flush out the warm air generated during the day. This system uses less than 10% of the energy of a similar-sized conventional building, saving enormous amounts of money and electricity. It is a powerful demonstration of how we can learn from the wisdom of nature to build a more sustainable future for ourselves. However, our relationship with termites is complex. While we are learning from them, we also see them as a threat to our wooden structures. It is important to remember that only a very small fraction of the thousands of termite species are considered pests. The vast majority live in natural environments where they cause no harm to humans and provide invaluable ecological services. Our challenge is to manage the few problematic species without harming the many beneficial ones. Protecting our homes is important, but we must do so in a way that respects the vital role that these insects play in the wider world. In the grand tapestry of life, every thread has its purpose. Termites, these small and often misunderstood creatures, are a crucial thread. They are master builders, expert climate controllers, and essential recyclers. They enrich the soil, support plant life, and provide inspiration for a more sustainable human world. Their existence reminds us that even the smallest of creatures can have a profound impact on the planet. By understanding and respecting their place in nature, we not only protect them, but also ensure the health and balance of the very ecosystems upon which we all depend. They are truly nature's architects, and we have much to learn from their secret lives.